In the last lecture, we developed this formula for calculating a conditional probability. That is, the probability of something happening given that we already have prior information that another event has already taken place. So in this lecture, we're going to look at some examples of the kind of questions you can answer with this formula. But before we do, I want to make a point about the order of events. Now, if you remember back to our conversations about counting methods, we invested a lot of energy in determining whether or not the order of an arrangement mattered or whether it didn't. Right? That isn't quite as important when we're talking about probability, but with conditional probabilities, you should keep in mind that there is an explicit order to the events. The B event has to take place before the A event. All right, so with that in mind, let's take a look at some examples. So first I want to figure out what's the probability of being dealt a jack, then a queen. And I've got our conditional probability formula here for us to work with. So before we jump in, I want to explicitly define what our two events are. Right, so A is going to be we're dealt a queen, and B is going to be we're dealt a jack. The event that takes place first, that has to be the part after the slash in the conditional probability part, right? So B is going to have to be we're dealt a jack. Now, referring this as the intersection is a little abusing the notation, because when we're talking about sets, remember, there is no ordering. And we do care about order here, so I'm going to be a little more explicit about this on the next step here. I'm going to replace the A's and B's with our events. So what I'm looking for here is the probability of a jack, then a queen, not really a jack and a queen. And that's equal to the probability of being dealt a jack times the probability of being dealt a queen, given that the first card was a jack. All right, well, the probability of being dealt a jack is 4 to 52, because there's 4 jacks out of 52 cards. And it's the second probability that's interesting. There are 4 queens in the deck, so the numerator is going to be a 4. But because we have already dealt that queen, and when you're dealing cards, you don't put them back, right? There are now only 51 cards in the deck. So the probability of being dealt a queen, given that you've already taken a jack out of the deck, is 4 to 51. If we multiply these two together, you get your calculator out. This is 0.006033. Okay, so how about if we turn this around? What's the probability of being dealt a queen, then a jack? All right, well, that's going to reverse our two events, right? A is now being dealt a jack, and B is now being dealt a queen, right? That's the conditional part of the last probability. And again, I'm going to be more specific. I'm going to say probability of queen, then a jack, rather than and. And that's the probability of a queen times the probability of a jack, given that you were dealt a queen. Well, the probability of being dealt a queen, that's 4 to 52. 4 queens out of the 52 cards. And the probability of a jack given a queen, well, that's going to be the same as we saw before. There are 4 jacks and 51 cards left in the deck, so that's also 4 out of 51. And again, you go to your calculator, you get the same amount. Okay, so now let's take a look at the general question. What's the probability of being dealt a queen and a jack? I've removed any consideration about order, right? Which is really what you care about when you're actually being dealt a card hand. Well, let's take a look. We want to do the probability of a queen and a jack. Well, we can split this up into 2 disjoint events. Either you get the queen, then the jack, or the jack, then the queen. Or because the events are disjoint, we can apply our probability property. Say this is the sum of the 2 individual properties, which we already calculated, right? That's these 0.006033 plus that number again, and we get the total probability, the final probability of being dealt those 2 cards in any order is 0.012066. Now, to confirm this, right, to confirm that we really are thinking of this correctly when we're doing this whole business being concerned about ordering, let's calculate this probability again, this time using counting methods. Right, so there are 4 ways to be dealt a queen, because there's 4 of them. And similarly, there are 4 ways to be dealt a jack. That means the total number of ways to be dealt a jack and a queen using our multiplication property is 4 times 4, or 16. Okay, so that's how many ways to get a success, so to speak. How many ways are there to be dealt a hand of 2 cards? Well, that's 52 choose 2, which is 1,326. And if we now go to our basic probability formula, it's the number of queen and jack hands divided by the number of 2-card hands, which, yeah, comes out to exactly the same number. So we are getting the same results regardless of which method we use. So in the next lecture, we're going to look at a somewhat bigger probability question. There's going to be more moving parts to it. And we're going to introduce a new method for analyzing a probability question called a decision tree.